Hi, my name is Austin Popejoy. I'm with GSE. I'm tech support as well as the CAM application engineer. And today we're going to do a crash course with Solidworks Cam 101. Solidworks Cam is a powerful tool that you have access to if you have a version of Solidworks 2018 or newer and you're on subscriptions. Because of that, the goal today isn't to make you a Solidworks Cam expert, but to give you the power and the tools that you can go through and start to explore on your own. So this will be the part we're doing today. As you can see, it's not overly complex, but there is a number of features that need to be picked up. So for those of you that are actually using Cam today, I want you to take a moment, think about how long it would take to program this with your current Cam software. And we'll do a time comparison in the end, because ultimately that's what we're going for. Anytime we can reduce the amount of time taken to program a part, we can get in production faster, we can get out the door faster, and that means more money in your pocket faster. So we'll go ahead and take a quick walk through the Solidworks Cam interface. First thing you may notice if you're familiar with SolidWorks is you have three additional tabs across the top. You have the feature tree, the operation tree, and the tool tree. And through one of these three windows, you can generally modify anything you do within SolidWorks Cam. A lot of new users seem to have issues figuring out where to go to modify what they want. And the way that I like to keep that straight in my head is the feature tree is what are you going to be machining? The operation tree is how are you going to do it? And the tool tree is obviously what tool you're going to use. In addition to those three tabs, you also have a SolidWorks Cam menu across the top. And what's great about this is if you get lost, you can start in the top left and work your way left to right, and that hits all the salient steps for programming a part. The first button, Define Machine, is where you enter in all your machine parameters. When you first fire up SolidWorks Cam, you will only have the mil-inch selected. Everything after that will be grayed out. And the reason for that is SolidWorks Cam Standard, which is what's available free, you can do 2.5 axis machining, which is where your tool comes down to a set Z depth and then moves in the other two directions. If you notice, I do have additional options, and those are because I'm using SolidWorks Cam Professional, which gets you pre-positioning of 4th and 5th axis as well as 2-axis turning, and a number of other features as we go through. When we hit some of those features, I'll be sure to point those out so you can know the differences between the SolidWorks Cam Standard and Professional. But for now, we'll pretend that we are using a Tormach PCNC 1100 machine. The next tab we have is the tool crib. This is one area where putting a little bit of time in the front can save you huge amounts of time in the back. This is basically where you tell SolidWorks Cam what tools you have available. You can either enter in what kind of tools are in the machine or what tools you have in your facility, and if there's something available, SolidWorks Cam will default to using that. So for instance, if it wants to use a 3/4 inch end mill, but you happen to have a 1/2 inch end mill already in the machine, it'll program with that 1/2 inch end mill, and that way you're not swapping out tools unnecessarily. You do also have the option down at the bottom to click the box for Use Tool Crib Tools Only, and anytime you try to make an operation that does not have a tool for, it'll simply throw up a warning. We'll leave this set to the default tool crib, but you can set that up to match any machine that you have within your facility. Next tab is Post Processors, and this is one area a lot of people have questions in, rightfully so. Everything you see on the list here is loaded with SolidWorks Cam as a default, and they've tried to pick roughly 25 post-processors that span the majority of the controllers out there. And it may not be exactly what you're looking for. You may have to do a couple lines of hand editing after your parts have been processed, but this will at least get you in the ballpark and allow you to continue to use SolidWorks Cam. In addition, any post-processor that works for CamWorks will also work for SolidWorks Cam. So if you Google CamWorks, your machine, your controller, and then post-processor, sometimes you'll get lucky and come across a post-processor to work for you. I've actually been doing that over the years through my travels, and I have roughly 2,000 post-processors saved. So odds are if you email me and say, hey, I have this machine, I have this controller, what do you have? I have something that's going to work for you. Worst comes to worst, you have a complete oddball machine, there's nothing out there that's going to work. You can always contact us at GSE, and we do also offer custom post-processor support. So we'll leave this set to the Mach 3 controller because that's what the Tormach uses, and we'll click OK. The next option is going to be the coordinate system. This is where you put in your work 0. If you look very closely, we have a SolidWorks coordinate system at the top left corner of where our stock is going to be, and that's represented by a SolidWorks Cam 000. You can also choose any corner of your stock. You can choose the middle point, or you can choose the middle point or corners of your part as well. Next button is Stock Manager, and as a default, this goes to the smallest cube that will fit around your part. You can choose a material type from this list, and when you do that, it'll update your feeds and speeds based on the material you choose. Now, if you happen to be using materials not in this list, Solidworks Cam does come preloaded with roughly 1,100 materials that all have associated feeds and speeds, so odds are we can have something that will work for you. We'll leave this set to the default 6061 T6 aluminum. To change the shape of our stock, we do have a couple options. You can either add additional material using the directions here. You can also use an extruded sketch, which is what we're going to do. And this works just like SolidWorks, where you choose a sketch, you give it a direction and a distance, and it defines your stock. Another option you have is you can use an STL file. So if you happen to get castings from a vendor, you can use those STL files they provide. Or if you're doing a multi-operation, you can actually save the results from operation 1 as an STL file within this software, and then use that as your stock for the second operation. That way you're not machining away material that's already gone. As the last option, you can use a SolidWorks model, either a separate model or a configuration of the same model to define your stock, so you can machine only specific areas. Now the next three buttons are basically the automatic feature recognition of SolidWorks Cam, and this is the biggest time saver you're going to find anywhere. By clicking Extract Machinable Features, SolidWorks Cam will look at your part, will recognize the SolidWorks geometry. So for instance, it picked up a face feature going across the top, it's going to machine off the top of that, the center bore, down the pockets, and so on and so forth. The next button, Generate Operation Plan, allows SolidWorks Cam to look at the different parameters of those features and figure out how it wants to approach that. So you see we have a face mill going across the top, and then we have a series of roughing and contour mills going all the way down. And last, we have the Generate Toolpath button, which will actually create the toolpaths. If you look at the tree, you'll see most of the processes are in black, and that means they're ready to be post-processed. But we do have a couple that are saved in pink, and that's on purpose. Look at this first one here. You see it does have a red icon around it. So just like anything in the SolidWorks realm, you can right-click on that, go to What's Wrong. It'll actually tell you what's wrong. In this case, the lead in and lead out isn't sufficient for going inside that bore. So to change that, you can double-click on the operation, and it pulls up your operation parameters window. From here, you can change the tool being used. You can either manually type in the dimensions here, or you can go to Tool Crib and choose a different tool. You can override the default feeds and speeds if you are comfortable doing that. The Contour tab is where you change all the geometry of your cuts. So if you need to add additional material to the wall, you can enter it there, and it'll leave 5 thousandths on the wall. You can also change your cut depth parameters here, a number of different features. The NC is your control planes, but we're focused on lead in, lead out because that's what it told us the error was. Anytime within SolidWorks Cam you see a number with a blue percentage sign highlighted, it means that's a percentage of the tool width. Change that, you can click the percentage button, and right now it's trying to do a 195 thousandths of an inch lead in. There's simply not enough room for that, so we can change it to something more reasonable, say 40 thousandths. Right click our operation and have it generate the toolpath. Now we do have a number of other operations that are highlighted in pink, but they don't have a warning. The vast majority of the time when that happens, it simply means there's no material left there to be machined out. And if we look closely, each of these operations has a roughing operation immediately before it that gets rid of all the material. So we can simply delete those out. That does bring up one nice point about SolidWorks Cam, is anytime you delete information, it doesn't actually make it disappear into space. It puts it in the recycling bin, so down the line if you change your mind and decide, hey, I actually do need to keep that, you can simply restore it from that point. With SolidWorks Cam Standard, you can only program using the parts. You cannot program using assemblies. Because we're in SolidWorks Cam, Professional does allow us to use assemblies, which is why we're able to model the device and such. But because of that, we do need to tell SolidWorks Cam which part of our assembly is a fixture, so it makes sure to avoid those areas. We can simply click on everything we don't want to hit. Click OK. And the other thing that does is when we run a simulation, it'll actually give us a visual representation of our fixtures. SolidWorks Simulation is a way to graphically give you your toolpaths. You make sure you don't have any interferences. And I'm going to leave the speed on this turned up relatively fast so we don't spend a lot of time just watching the animation go. So now that our animation is done, we can check the results. And in order to do so, you have the green box here that says Show Difference. If you click that, it'll compare the materials left to the part itself. So if we look closely, there is the mounting holes that are not picked up. And then also, we have a lot of material left around the outside. And that is actually by design. I found that I can set this up to do it automatically, and it looks beautiful, but in reality, that's not a realistic expectation of what you can expect to get from Solidworks Cam. So I leave those two out, and that allows me to show you how to program features manually that aren't automatically picked up. So to program these manually, we need to go into the feature tree, open up our feature manager, right-click on our mill part setup, and first we're going to start with a part perimeter feature. So the options we have for a perimeter feature are boss, which is going to do a single tool width around the outside of the part, or open pocket, which will get rid of all the excess material on the outside. You can also choose the finishing strategy you like, but we'll leave this left to rough and finish. And you can also set the tool depth. So in this case, it'll go to the bottom of the part, and we'll tell it to go 0.010 of an inch past just to make sure that we're clear. You can click the OK button, and now you see your perimeter feature is added to the list. Next, we're going to right-click on our mill part setup and do a 2.5 axis feature for the holes. So here you can choose what kind of feature you'd like to select. In this case, it'll be hole. Choose your geometry, and click the end condition button. And this is where we tell it how deep we want to go. We'll tell it we want to go 1/4 inch deep on these holes. Click the green check mark, and now we have the circular pocket feature added to our feature manager as well. And click both of those and have it generate the operation plan, and then generate the toolpath for those operations. So now we can graphically see the toolpaths, and looking at it, there's a lot of extra movements within this part perimeter feature. And if we look closely at it, it's programmed right now only to use a 1/4 inch end mill. In order to change that to something more realistic and a little more efficient, we can either double click on it and open it like we did within the operation manager, or we can simply go to the tool tree manager, find our operation, in this case roughing mill 15, click on it, and drag it to the tool we want to use, a 3/4 inch end mill. By doing so, it does automatically update our toolpaths, and that should save us a large amount of time. One last thing before we finish up is on the right side you can see what tools are being used. And if we look, we have a 2-inch face mill, a 1/2 inch, 1/4, 3/8, 3/8, 1/4. There's a lot of extra movements and a lot of extra tool trays in here that could cost us time. So in order to change that, we can right click on our mill part setup, tell it we're going to sort operations, turn off process complete feature, go to the sort tab, and it'll sort by operation type and then tool type. If you want to adjust this, you can simply click on your roughing mill and move it up above your drilling operations. So now do facing, roughing, then our drilling, and finally our finishing operations. When you click OK, that rearranges your operations to a much more realistic pattern. One more time, we will simulate our toolpath. Compare the results, and we're ready to post-process. In order to generate your G-code, you click the post-process button, tell it where you want to save your file to, and then click the play button, and that'll generate your code. One option I always recommend turning on is if you expand the options window, you have the option to open up the file within G-code editor. If you have a current CAM program, a lot of this will probably look familiar. You know, there are a lot of code editors out there. This one has all the standard features. You can hand edit your code. You can compare two programs, see what's changed, any number of things. But one option I really like is you do have the option to backplot your program. And what this does is it actually reads your code line by line and gives you visual representation of what's going to be entered in your machine. If you do this long enough, you'll program something within the CAM program and it looks beautiful. You generate your code and it throws a random line of code that doesn't agree with your machine, and that can cause a lot of issues, a lot of loud noises, and cost you a lot of money. So doing it this way will actually give you a visual representation and make sure that what you're expecting is actually going to be generated to your machine. And one step further, you can click the mode button and animate from start and move line by line to make sure that everything matches up with what you're expecting. That's a short little check that could save you a lot of time, a lot of money, a lot of headache in the future. So we'll close that out. And now that our code has been generated, we're ready to set into shop floor. And this is one area that Solidworks Cam really excels. As opposed to some of the other programs that are out there, Solidworks Cam saves all of your programming and all of your information within the part itself. And that does a number of things for you. One, you're not working with an exported file, so you're never quite sure that you're working with the current version. Everything is within the same interface, so you know as long as your Solidworks part matches, is updated, then your machining will be updated as well. Because of that, you can also pull any additional information just like you can with any other Solidworks part. So for instance, we can open up a drawing. And this is representative of most companies' setup sheets out there, but it does use the Solidworks technology in that it pulls information. So it tells you what part's being machined, who programmed it, those are my initials, the machine we use, the post processor, the G-code file where it's saved so you can make sure you can always find it afterwards, as well as the date and time this was generated. In addition to that, you have a visual exploded view of your entire assembly. It tells you what work offset is being used, as well as where that's located. And it gives your operator a nice bill of materials so they can just make one walk through the shop, pick up everything they need, and be ready to go. So let's say hypothetically we program this using G54, and you know what? Actually that work offset is taken, so we need to change that. We can go back to our coordinate system, change the configuration of that to an open work offset, say G58, generate our code again. I'm not going to bother with the G-code editor because I'm relatively confident that we're going to get a good program out of that. And if we go back to our drawing, it now has the updated work offset as well as the new time for this program, so you can always make sure you're working with the latest and greatest. Now, I'm not going to say this is 100% operator proof because I've seen some very skilled operators when it comes to crashing machines, but this is about as close as you're ever going to find. So we've run that through our machine, everything looks great, and we're ready to go to production. Now realistically, if we look at this setup, our part is set up in the middle device, and that's not how you do a production run. If you did it like this, you'd have to zero off that corner every single time, and it'd be a huge waste of time. So with SolidWorks, you're allowed to do configurations that represent different setups. So if we move to a left setup, you see our part has shifted to the left, as well as our work coordinate system has gone to this corner. And the way this will work in the production world is you put a parallel up against this vise, butt your stock up to it, and you'll be in the same spot every single time. Because of the way that Solidworks Cam is integrated with SolidWorks, now if we open up the Configurations tab, it's smart enough to recognize, hey, you're using a new configuration within SolidWorks. Would you like to copy what you've done so far into a new configuration within SolidWorks Cam? Now, configurations are a professional-only feature, but that right there is a huge time saver, and to make sure that everything matches up. We'll let it regenerate the code. Simulate our toolpath. And now everything has been moved over to match this new configuration. So now I want to circle back to what I talked about in the beginning. This entire part has been programmed for prototyping, the setup sheets have been done, and it's been reprogrammed for doing a production run. And it's been roughly 12 minutes or so. So if you kind of think back to how long your current process would take to do this entire process, there's no doubt you'll see the amount of time, this time savings potential there. And that's really what we're looking at. The majority of the time when you run Solidworks Cam, it's not going to give you a production ready program with 3 simple clicks. But it'll get you 85–90% of the way there, and from there it's just a matter of tweaking what you're doing and getting it dialed in really. It saves a lot of the monotonous day-to-day operations of doing every individual program by hand, and that chews up your time and also invites human error. One last thing, if I can plug this, is the great thing about SolidWorks Cam is it brings all of your SolidWorks and your CAM support under one roof. If you're using a different CAM program, say MasterCam, and you're having issues, it comes down to, is it a SolidWorks issue, is it a MasterCam issue, and you don't really know who to call. If you have an issue with SolidWorks Cam, you simply call up and say, hey, I'm having an issue with programming this part, and they'll put you through to me. So similarly, if you have any questions after watching this video, feel free to give me a call or shoot me an email. I'll be more than happy to help out. Thanks a lot.